So, good evening. I'm Satish here from Pragnan AI. So, we already completed the Python. So, and also I have given the evaluation. Some people submitted the evaluation. So, others who have not submitted the evaluation, please submit the evaluation. Those questions are very, very important. So, and we also will discuss, I will give another set of 35 question and another 30 question, total 100 question I will be giving. So, important questions which you should be doing it. Other than that, like I will be giving another 100 question as an assignment. So total 200 programs I will be giving. So you should be studying them, practicing them, and so that like your logic will become effective. So now that is about Python. So now what we will be doing is actually like after that, now we will be studying the essential things necessary for us to do deep learning and machine learning things. Like, so this is all about data science and AI. So we will be studying data science and AI. So when we wanted to build a machine learning model or a deep learning model or anything models to be built actually, like we'll discuss actually what is machine learning, what is deep learning. For some people we have not discussed, some people we already discussed actually. So somebody who doesn't know machine learning or deep learning, so machine learning, deep learning is actually the model, the programs where we are not writing any algorithm. Algorithms will be automatically written by themselves, but only what we need to do is actually we need to give the data to get trained. So for example, in the normal approach, when we say, so if I want to find out a number is prime or not, so then I'll be writing algorithm for prime numbers. So if we give a number 5, so this is my algorithm. So we'll write the computer algorithm, the code, and code will be executing in the computer. So if you give 5, then it will give output what is called is a prime or not. Prime or not. This is how the normal programming concepts. So in the machine learning, what we will do, there is a 2 phases will be there. So first phase actually training phase and second phase actually testing phase. Like here, what will give? See, what is this 5? 5 is input. What is that prime number not? That is output. So this is output. So what we will be giving? We will be giving input and we'll be giving output, and we'll ask the program, the model, whatever say machine learning model, so that like you give me the logic or algorithm or the model which is trained for that. So for example, here if I say 5 is that, then I will be saying it is a prime, and I will give, this is one input. Second input actually 6, not prime. Then again another input is actually like 8, not prime. So 11 prime. So I will be giving input output here, and I'll ask the model, machine learning model, to get trained on that and build the model which is understood. So next what I will be doing, I will be using model. So next what I will be doing, I will be using this model to evaluate whether it is learned properly or not. So now what I will be giving, so next when I'm trying to run the model, then I will give 5 or I will give 13. Then you should give me output what is called is a prime number. So this is what. So if you're not giving, then the model is not properly run. So this is how. Here we are not written the logic. So logic is completely derived from the machine. So these kind of models are called machine learning kind of models, where model get learn from the data. So here, what is important for us actually, we need to feed the data to the model. We need to feed the data to the model so that like model first start learning, understanding the pattern. So in whether it is a machine learning, whether it is a deep learning, whether it is a NLP, or what is the bot or AI bot, whatever we see, anything when what we say, so this model has to be get trained. So there are 2 steps are the model has to be get trained. And then when model is get trained, then I will give input and it will give output. So one is a training phase, another is a testing phase. So during the training phase, we need to prepare the data. We need to prepare the data. So whatever the way, so we need to prepare the data in the way to train the model. So this data preparation or the model data needs to be prepared in a proper format to get trained for the model. So this data. So now to prepare this data, we should know, understand what kind of data are available. So we may be having something like the Excel sheet kind of a data, where we'll be having this is column and the row. So something that like, or CSV, Excel sheet, all those kind of a data. So that is one kind of a data. Or data maybe from database, where we will be having rows and column, again the structured kind of a data. or data can be something else. So data can be numbers, images. So data can be image files. Data can be audio files. So audio files, like, so we need to give the prepare audio files and then feed the audio files to model. Or it can be video files. It can be video files. So, or it can be text files. Like in ChatGPT, we'll ask them some question in the text, and it will give response in the some kind of a text. No, so it may be text. So text may be the input data type, audio may be data type, video may be data type, image is the data type, or tabular kind of a data types, or it can be something that like a database kind of a data. There are various kind of a data types will be there. So if it is a text kind of things, if it is a file kind of things, then we need to use something like a regular expression, or we may use something that like a natural language processing. So there are two approaches where we will be handling the text handling. So text file. So it's like we wanted to find out certain specific patterns or like search something like, then we know how to do using regular expression that we studied in the Python. If it is a tabular kind of a data, so then we need to use pandas libraries to do something like a processing of a data and all those things. Like, so tabular data will be something like this, like, so what we are discussing in the machine learning classes. Most of the files will be in the CSV format. So let me show some tabular data. So data will be in terms of CSV files. Let me show that actually. So data may be in this format. So then we will be reading using pandas libraries, and then we'll be doing some kind of operations. Like, so we will study NumPy and pandas. So as further things, like, so data will be something like this. So it's a CSV file. So it is a tabular form actually. So we will be reading. So to reading this data and then processing data. So to read this data and process data, we exclusively use pandas library. So, and the data may be of the in terms of image. So if it is an image, then what kind of processing, what kind of operations we'll be doing. So whether it may be audio, video, and image. So we need to have some specific kind of a processing libraries. So we will be studying another libraries. So for tabular kind of data, we will be using pandas things. So that we should study pandas. So for image kind of things, so if the data is in terms of image, then we will be studying what kind of image processing we can do, what kind of libraries available to process the image data. So that like we do all those basic operations of the data preparation. We are not studying the image processing as such as an electronic subject, but we are studying what is essential for me to prepare the image data to feed to the model. So that like model get trained on the image and then generate the output. So the output may be anything. So classification, all those things that we'll discuss. But objectives, why we were studying this kind of things, like so many applications are there. Medical image analysis means like if you give an X-ray image, then it will say that like whether the person is having COVID or not COVID, or whether we having cancer or not cancer. It's like first to understand that actually you have to understand the image, correct? So I cannot directly feed. So I need to do some kind of a processing before we start feeding to the machine learning. So image, geospatial computing means like satellite image and computing, surveillance, CCD camera, robots which are seeing it and operating now, so they're analyzing that like who is that person, driverless car, automotive, lot of places like this image processing plays an important role. And we will be studying like what are the basic essential processing we should be doing when we start building the deep learning models. Usually most of the things is in the deep learning models, so we will be studying for that objective. So you should know that like the context why we should study. So that like I give the context when we are discussing about regular expression, because text processing we should be doing. So here image processing which we should be doing, because image is also one type of data we should be feeding to the machine learning or deep learning models actually. So fine. Any doubt? Anybody has not understood the context? Why should we study this one? And it is not like we are not covering an entire thing what you study in the image processing class, because that is not necessary for us, and we will be avoiding all the algorithms and mathematics. But here it is completely practically how we should be processing it actually. Like for example, if somebody is given an image, what all things we should be doing, the practical thing. But still we need to know certain basic foundations. So what are the essential basic foundation necessary, that we'll be discussing. So okay, so any questions so far? Anybody has still doubts? So the next thing what we will be studying is actually there are two type of images will be there. One is vector, another is a raster kind of image. So vector kind of images are the images which are created using what is called using some kind of lines, curves, shapes. So it is something like a analog kind of a image which we using these kind of natural curves or lines or something which we are trying to create. So that is some kind of is a more kind of a like a finer kind of a image. So other thing is actually raster kind of image. So when we say raster kind of image, it is a digital image. So which we take digital camera using digital camera, what we try to do, or we when we convert from the analog to the digital, that what we get. So what exactly it will be? It will be something like this. Let me show. So if I see an image, so image it is not looked as a some kind of a lines or curves. Like so, if you see an image file, so what we will be seeing, the image will be divided into multiple kind of rows and columns, and that is called a pixels actually. So we will be calling, so we will be dividing this image into certain segments. So now this is assumed that like this is one small portion or something of an image, and this will be mapped to certain value. So it will be having a pixel values or values which will be say what is that exist in this bit position. So that is called bitmap. Bitmap file is actually, so that bit having a value, so that value says that what kind of information exists in that bit position. So it may be some numbers. Like let me show you that. Like I will show you some. So let me show you one tool. Uh, so just I wanted to showcase actually like how exactly image looks like. For electronic students, I think they already know. But for IS or CS guys, like let me try to open one parrot image. This is JPG image. So when you see that actually that everything will be stored as a binary number. So if you see actually there everything is a binary values. So there will be binary kind of a values. So it's like when we discussed in the file handling, so any file will be opened in normal text mode or it may be opened in the binary mode. So all these audio, video, we should be opening in the binary modes, and all the information what we see in the file. So this is a file. So all we see is actually binary numbers. So because these are all numbers, and what is this says actually? This is 00. It's like something that like image will be stored something like this. Like let me show that actually. When we show image like something like this, so this is how the x-axis, this is how the y-axis, and 0 will start from here. So 00 means like 00 the value. So in this bit, what is the value here? Or in this one, the value is ff. So value is ff. So means like in this location, the value is ff. That is ff is hexadecimal value ff, because I'm using 1 byte to store a value. So that value. So everything will be considered. Like if you want to look for this one, so that is a 0 and 1. So 0, 1. So you will be seeing 0, 1 is this is a value. So it's like D8 is a value. So it's like for every bit, every pixel, there will be value represented depending on what kind of image. So certain kind of values will be there. So image will be just the binary numbers. So if you see that, if you read the image in the binary format, this is what we are trying to get the value. Any question here? So far, so the raster kind of images will be having a bitmap. Means like they will be having the numbers which you should be looking into. It's like so it will be having some kind of like, so if you look closely, look here, so it is all in terms of pixels, like so many pixels are there, and each pixel will be represented by one value. So that is why it is called bitmap image. They can also call as a bitmap image. Also they are called raster files. They are also called a digital photography or digital images actually. So any question, anybody not understood these two terms, vector and raster? Any doubts? So when we see the raster files, it will be in terms of pixels. When we see vector files, it will be in terms of lines, curves, and shapes. It's like if lines, curves, subshapes, it's like what using that we will be creating. So for example, if I have to create a design or drawing of a person, what I will be doing, I will be doing circle and then another circle, then straight line. This is a face of a person. So we will be using these lines, curves, and all those things. Then I'm trying to create images actually. So those kind of things called vector kind of image. So it will be from that. And we can convert from this kind of vector kind to raster kind of things by that is called digitization. The process is called digitization. I'm trying to do it actually, like there is a process is there, so I'm not going deeper into that. But if you wanted to convert analog to digital, there is a process. There is something called a sampling, there is something called a quantization. So using the sampling and using the quantization, I'm trying to convert which is a analog value in terms of a digital value. So let us see that, like one simple example, and then I will come back to there. So this is the analog signal. So if you wanted to see, so this is analog signal. So this analog signal I wanted to convert into a digital signal. Then I need to take a sample, means like I'm trying to read values at certain position. So I'll be reading values at this point. I'll be reading values at this point. I'll be reading a value at this point. I'll be reading a value at this point. Well, I'll be reading value at this point. So means like, so in this one cycle, I'll be reading at like around 10 times, 10 positions where I'll be reading the value. So what is the value? So I'll be reading this. This is a value. At this point, this is a value. At this point, this is a value. At this point, this is a value. And at this point, this is a value. Means like I need to decide how many times I want to take the value. So if more samples means like I need to take at minor granular, or less samples means like I'll be taking less than. So when I take that as a samples, like someone's like, now I got some values. These values, whatever we got, will be converted back into a digital things. So means like I have taken at this multiple samples things. So now what is this 40? How should I represent this 40 using certain number of pixels? So 8 bits, how should I represent 40? So now that is called quantization. Quantization actually converting that value into certain kind of binary numbers, certain kind of a number. So one is actually samples. So how many times I want to take? So if you take more samples, so if you take less samples, if you take more samples, so depending on that, so if you take more and more samples, like so things, then it will be better and better image. Like if you take less number of samples, so will be something like a badder and badder kind of image. Like so, for example, see by factor of 2 means like what I'm trying to say actually, if you take more samples, like so per images, if you take more samples, so number of samples more, then the image will be more and more bright, granular, and like picture quality will be good. And if you take less number of samples, like 16, 8 total. So this is actually by factor 2 is actually like what I'm trying to say actually, number of samples what I'm trying to take. If the more number of samples, the finer kind of image, less number of samples. And finally, like what I will be doing, I will be converting that sample into some kind of a numbers. Like for example, at this location, so the value is something. So this is the value maybe 0, 1, 2, 3, 4. This is what I got. So at this point, value may be 2. So these two values, how should I convert? So how should I convert into a digital number? So I will be using 2 bits, I will be using 3 bits, I will be using 4 bits, I'll be using 8 bits, depending on how many bits you wanted to use. So that is called quantizations. Like using 3 bits, if you wanted to represent, every pixel is represented by 3 bits. So I will be using, it's like what is the maximum possible values are possible with the 3 bits. So up to 8, 0 to 8 levels. It's like image I will be dividing into 8 levels. Like so, for example, whatever the image will be there. So this image, analog image, I will be dividing into 8 levels. So because I'm using 3 bits. So if I'm using 8 bits, means like I'll be dividing 2 to the power of x, like 256 shapes are like 512. It's like so if you divide that into more and more granular, if you use more and more bit, means like I will be representing more and more granular values. Means like so there will be 0 will be there, there is 1 will be there, or like if you take the value and amplitude you want to divide into only 2 things, means like it may be binary values, means like true or false. If I'm using only 1 bit, then I'll be saying that like the black and white, like so 0 means like black, one means like white. So then I'm using only one bit. So if the image I wanted to just represent by black and white, then I'll be checking actually value at that point it is a black or it is a white. So, or if you wanted to have that, like I wanted a grayscale kind of image, I wanted more shades of the gray, then I'll be representing so many. Like, so if I want 256 shades, means like I need to represent the number using 8 bits. So that is what will be decided, because I'm not discussing in that. So that is the process of converting from digital to analog to digital. So there are two steps, sampling and the quantization. First, I'll be deciding what is the samples, how many samples I want actually per cycle. And then I need to say that like per sample, how many levels I want to represent that value. That is a quantization. So using these two, I will be converting that analog signal into digital signal. So what is that I'm trying to say is actually like all these raster files are digitized files actually. We will be able to convert from the something that like analog to digital. But what happens actually when we try to convert from raster file to a vector file to a raster file, there will be loss of some information because we won't be able to get the things. Like for example, in this case only, let me show that like if I'm taking take a sinusoidal signal. So if you take a signal something like this, I'm trying to take at few samples. It's like I'm taking sample at this, I'm taking sample at this, I'm taking sample this. It's like, so this value will be represented this, then this is this. So now how is that actually? Like initially there is nothing will be here. So suddenly this, then suddenly this, then something like this. So this is how the thing will be there. So this is the analog image and this is the digital image. So it will be 0 value, then suddenly this value, suddenly this value, then the drop, then again, so something like this, then again something like this, then again something like this, so something. So this is the digital value and this is the analog value. So see here, actually something, but somewhere else I'm making some extra. Actually something, somewhere else I'm making the less value. So because of that, like there is some kind of approximation is happening. Approximation is happening in when we convert analog to digital. So, and that is the reason there will be some loss of information. So some kind of loss of information happens when you convert it back. So even if you convert from raster to vector, so again that loss of information doesn't recover it back. So that you should be remembering. So because of that reason, what happens actually, vector images is scalable. If you zoom it actually, you won't see that like image is getting distorted. But if it is a bitmap kind of image, so if you zoom it actually, the image will become blurred and may not be like so. That is what we have seen. No? So if I zoom this one, so this is how it looks like. So here, if you zoom also, still it looks like very clear kind of things. So that is the disadvantage of the raster fields. But like any file which is stored in the digital in the computer has to be a digital image, digital file actually. So raster image only. Any question? Anybody not understood what is the difference between vector and raster? And what kind of file formats are vector and what kind of file formats are raster? So .gif, JPG, PNG, TIFF are all kind of a raster files, and all others like AI, CD, SVG are like a vector kind of files. And in image, when you see that, like we will be seeing a lot more file formats. It is not just only those file formats. Let us show that like what all the file formats exist. So these are the file formats exist actually. So many file formats exist, but they will be classified either raster or a vector. So whatever it may be. So this is, and depending on like every file format has a different ways of storing the informations. So when you see when we try to process images, we will be seeing different kind of file formats. So different kind of file formats, but we need to know how to process that, how to convert into one file format to another, and then now what kind of processing we can do. So that is what is the objective of today, not only today's session, but like multiple sessions we'll be covering. So how should we deal with different image files? So any questions so far? Anybody not able to understand these two terms? So any doubts? So there is a certain file formats are of vector type, some file formats are raster type. Okay, everyone understood? Okay. The next is actually like another way of classifying the images are is actually based on the color. Based on the color, how I will be classifying? So I'll be classifying as a color image or a black and white image. So black and white image, and there is one more thing is called grayscale kind of image. So we'll discuss what exactly. So when we say black and white kind of image, then I will be having only two levels. One is the black and one is the white. But what is that actually? Like later on, they wanted to create a shades of black or shades of whites, and that is how like so many shades we are trying to create. So now grayscale is actually between black and white. Let me show here actually between black and white we will be having so many shades. So this is a white, pure white, this is a pure black, and in between we see so many shades of black and white. So from converting from black light towards the light white actually white. So we have so many range of values. So this is represented by value 0, this is represented by value 2. It's like we have 256 levels. So in grayscale, so even if it is a black and white, but there is a shades of black and whites, total 256 levels are there. So that kind of image is called grayscale image. So it is also some extent black and white, but like it is a refined kind of a black and white kind of image. So next is actually in color image. So we will be having not just one vector. So just like when we see it, no, when we see any image, we will see this number. So this is a two-dimensional vectors, no, almost like rows is there, column is there. So we won't be seeing the only one vector file. So we will be seeing three vectors, one for red color, another for green color, another for blue color. What is the intention for this actually? Any color will be created using three different colors. These are the base colors. Using these base colors, we can create any colors. Like if you are not able to understand or visualize, let me show that one. Let's see. So okay, so if I say you wanted to create just red, so I will say red values is 255. So now it becomes a red color. So rest the green channel value will be 0. So means like if I wanted to represent a pixel as a red pixel, so then I will be giving in the red channel. So value will be 255. So in green channels corresponding point. So it will be both will be pointing same position. So if you see here actually, this is a 0 0. This also 0 0. This also 0 0. So here it will be 255. Here it will be 0. Here it will be 0. So to then it will represent a red. So collectively this point represents a red color. So now if you wanted to represent a green, so I wanted to make this is 255, rest will be 0. So means like, so here in the red channel value will be 0, green color 255, so that it represents green. So if you wanted to represent blue, so here it will be 255, so rest will be, so means like now it looks like blue. So if you want any other color, we'll be having some combination values. So if we create some combinations value, this is how the color will be. Any color can be created using. So like if I make all equal, so this is the color. So if you want, so it's like by changing, we will keep on changing the color of the image. It's like using these three basic colors, we can create any color. So that is the reason when you say color image, so it is also a vector, just like in grayscale kind of a vector, but like here we will be having three things. One is one vector for one channel for red, one channel for green, one channel for blue. So means like color image will be having three what is called vectors. Any question? So any question, anybody not understood what is the color, grayscale and black and white? Any doubts? Okay. The another term like so black and even if it is a black and white, there will be shapes of black and whites will be there. Like so some shapes of black and some shape of whites will be there. There is no pure black and white is not there. So almost all images will be grayscale kind of image. That is you should be knowing. Then other than that, like there is one more term called monochrome. So what exactly monochrome means? Like monochrome is like mono means one, color, chrome is color, one color things. Means like so what is the grayscale is actually the shades of white or shades of gray, black, we can say anything we can say, but that is one color only. But when you say color image, there will be three things. One is red and green and blue. But if you wanted to make it only yellow shades or only green shades or in red shades, then that kind of image will become monochrome image. Monochrome image will be having one color and shades of that color. So if the image is created using just one color and shades of that color, that kind of images are called monochrome kind of images. So grayscale is also a monochrome. Only red channel also becomes a what is called monochrome. Only green channel will also become a monochrome kind of image. So any question? Who doesn't understand? Because this is a basic foundation you should be knowing. Because and then we will jump into the coding section. So any questions? Anybody not able to understand these terms? Color, grayscale, black and white. What is meant by monochrome? And other than that, like color also will have some other characteristics or some other things which impacts the color image actually. One is light, luminosity, and brightness, contrast, and all those things that we will discuss. Like these are some of the, you can say, attributes of an image. So by changing contrast, the image will change something. By changing brightness, we can change something. So lightness. So we'll discuss actually. These are all some kind of a features or like some kind of a attributes of the image, you can say. So we need to know these things, because so if we wanted to fuse some image, we wanted to enhance image quality, so we should know that like whether we need to enhance the lightness, brightness, or the contrast of the image or something like that we will discuss. But we should also know that like this, other than this color thing, we also have some other things called lightness, average, luminosities, and all those things will be there in the things. So any questions so far? So what we will do now, so instead of jumping directly to the color conversion, so we'll try to see that like what kind of libraries we'll be learning to process image. So there are so many libraries are there. We will be learning here in the course of like image processing. So one is a PIL, that is a pillow library. So I said no, like in our program, if you look at actually like for the data science and AI, we'll be learning around 50 libraries. So like Python is one, then other like NumPy is one, Pandas is one, like around 50 we will be learning. So in the whole curriculum. So in that, like we little bit like learn the Python and then some extent about the Python related libraries. So in the image processing, we will be learning about PIL, skimage, and NumPy also some extent, and OpenCV. So other than that, like there is TensorFlow also there. There is some image processing can be done using TensorFlow like, APIs and something like a PyTorch. But TensorFlow and PyTorch, we will be discussing as and when we are using that. But it is a little bit like a difficult for the people, beginners will be jumping into TensorFlow and PyTorch. But the thing is like most of the times, we will be using only these things. That is more than sufficient, unless until if you are trying to do something like a PhD or R&D or something, then you can look into, because whatever we are covering is more than enough for any. And if you think about our curriculum and models, actually it is far ahead of any of the curriculum available in the market. So the deeper level what we enter into, and we'll be studying these libraries little bit like a deeper, not like just like basic kind of things. We will go little bit deeper into those libraries, so that like then only we will say that like we understood, like the way we enter into Python deeper. So there is few more models are there. We will be covering that also, so that like we can go some more deeper into Python beyond the normal people what they achieve. So that is, and we also go little bit deeper into these libraries when we study. So any questions? So first we'll start with one library, then we'll do, because there is a repetition, like when we do with one library, same thing, how can we do with another library? But first one will go slow, second and third will go fast, because it will be completely, only thing is like library get changed actually. So first one will go slow, the second and third will go faster. So fine. So any question? So any doubts like what is meant by analog image, digital image? So analog to digital, the steps actually like sampling and quantization. So briefly I explain, because I don't want you take a image processing class here, because but whatever you necessary to know, I'm explaining that. Fine. So what we will do, so let us jump to the how should we start processing the image file. So let me go back to the Google Colab. Any doubts before I open the Google Colab? Any doubts? So let us start the image processing. Means like first basic operations, what we'll see, how should we read an image, how should we display image, and how should we save the file. So that is what we see, whenever we open any tools. So how should we create a file, open a file, read a file, write a file, and save a file, something like that. Like, so here we will study. Before we jump into that, so first we should be installing all these libraries, not pre-installed actually, we should be installing. Only NumPy will be pre-installed, but other things like OpenCV, if you are using, you should be installing. If you are using sklearn or all anything, if may not be pre-installed, you should be installing. Even TensorFlow, you should be installing. PyTorch, you should be installing. So all these libraries we should be installing. So how should we install? Hive explanatory. Pip is something that like a pip is actually a tool which is installation tool. So manually we are installing now. So programmatically, if I have to install, I should be using a tool called pip. So how should I call that pip? So explanatory pip. Means like if I have to run a Python program, explanatory Python, something like that. No? So here explanatory mark and pip. Then what operation I'm trying to do? I'm trying to install, uninstall, or upgrade, all those kind of operations. No. So I need to inform that like what operation I wanted to do. So install is the operation, and then the library name. So this is a library name. Pillow is a library name. So this is how I will be installing. Any question? So you will be doing a lot more installation. So you should be comfortable with this pip. So fine. Next thing actually, like I wanted to see that like I wanted to upload an image file. Any doubts? Okay. So next thing is actually I wanted to upload a image file. So how should I upload a file? Because I wanted to read a file, no? So I don't have an image file. So I need to upload to the Google Drive. So or Google Colab. So then I will be using it. So how should I upload? I should be calling a library google.colab. Then I should be importing files because all I want is file upload, file download. So from the google.colab, I'm importing files. So then I'm saying files.upload. So the function, so I'm calling. So now the files will be uploaded. Like, so let us run this actually. So I wanted to upload a file. So let me read any file. So let me read the image, parrot image. So now let me see this is a parrot I'm trying to read. So now I'm trying to upload the file. So the file is uploaded. So whether need to see that like whether file exists. So ls is a function which will say that like which file exists or not. So all files exist in the current path. So what is the current path? If you want to check what is our current path, there is a pwd is there. So cp. So it will give that like where exactly we are there. In this /content folder, these files will be there. Like so we uploaded a file called parrot.jpg. So that file exists. So that is what we looked into. Any question? So uploading. So you should not be having any question about uploading file to Google Colab. So something if you are trying to use some files which is not there in things, so you should be uploading. So there are two things you should know. One is mounting the Google Drive, then accessing the files from the Google Drive. Another one is uploading to the Google Colab and then using it actually. So and downloading also. So download is just like files. We'll discuss actually. Files.download will be there. So if you want to see, you can see that actually. So these are the basic utility functions you should be knowing, so that like you will be comfortable in operating the deep learning and machine learning, because we need to upload data or we need to download the model trained or something like that. So we need to know those things. Any question? So this is the basic things. Like, so we are not even started. So now since we installed the library, so I should be importing. So from PIL, I'll be importing image. Image is a something that like the PIL is a main class, something that like a main package or main method. In that image is a sub model, you can say model. So it has all image related kind of functions in the image things. So I should be importing that from PIL import image. So I'm trying to import that. Then what is the other basic operation I will be doing? Opening a file. So I'll be image.open. Then I should be giving the file name. So whatever the file name. So parrot.jpg is a file name I'm giving. And I'm whatever the return value I'm assigning to something like this is a variable. IAM is a variable I'm assigning. And then to display the image, so IAM.show, and it will be displaying the image. So using PIL, just read the image using open, and then by using show, it should be. So see, this is not on this image. It is based on the variable, whatever the variable, on that variable dot show. So this open is from this image. So this open is from this image. This show is from this library, the variable dot show. So this is how I will be displaying the image. Any question? Any doubts? So these are basic operations: opening a file and displaying the file. Image we need to display, correct? And names are very easy: open, show. Fine. Okay. The next thing is actually, if you want to see that, like, what is that IAM? IAM is of type pil dot jpg plugin dot jpg file. So this is the of this is variable of type JPEG image file. So it is a type of the variable. So here, like, we need to define the type of variable, no, automatically dynamically type. So I'm not mentioning type. So I just want to check what type of that variable is there, because of type JPEG image file. So just like in the file handling, we said no, file has an attributes, no, file handle, and then check the attributes of the file, correct? So here also we wanted to check the attributes of that file image. So what are the attributes? One is the name. What is the file name? Dot IAM dot file name will give file name. Then what is the format? What format is there? File format. It is JPEG file format. So some more extra information about the file format. JPEG file format, it is ISO. See, all these file formats are part of an organization. There will be standardization committee, and they will define the specification for that. So even ASCII also has some organization. So for JPEG also there is organization. For everything, for PNG there is organization. So all this, like Excel there is organization. CSV means like all these file formats, like PDF, Acrobat is the one which will decide. So it's like everything, there will be some kind of organization, some kind of a group or some kind of a company which will take ownership and does that kind of things. Like, so this is of ISO things. So this is if you read ISO, this document, it will explain how the JPEG file format should look like, how should we store, how should we access, how should all those things related to that. We are not going deeper into that, because if you are interested, you can look that and you can explore that. Fine. So the next is the mode. So is it images of which mode? There is a grayscale mode, or is a color mode, or in color also there are so many different type of modes are there. Color images are there. So we'll discuss that in further. So now right now it is a RGB. So the images of RGB. It's like a color image. Any question? Okay. The other information is actually size of the image. So another information is size of the image. So what is that actually? This is a width, this is a height. So what we are trying to notify. If you see here actually, where was that actually? It is done. Okay. So now let me write it actually again. So when we open an image, so something like this, like, so this is our image. Where was that? We've opened the image. See, if you see here actually, what is that image? So it will show certain kind of things, like, so it will this side and this side or something, that like it will try to show. So how is that image will be? So image will be represented something like this. So now when I say 1200 by 625, so this is this side, it is 1200. So that width is 1200 and the height is 627. So what is that means actually? So we will have so many pixels. So it's like I will be dividing this width, something that like I will be dividing these things like these 1, 2, 3, something like around 1200 I will be having. So this one height I will be dividing like this 627. So 627. So now, so here it will this all the axis will start from here. This is access point. So this side is 0, this side is 0. So this is axis like this, this is axis like this. In the normal mathematics, axis will be something like this. No, this is x-axis and this is y-axis. So correct. Here, this is a width. This is x-axis. This is y. So this is called width. This is called height. So correct. So this is how it will be. So it's like this is 0. This is 1. This is 2. This is 3. And this is actually this one. Last one is 1199 because it starts from 0. So here will be 0, this is 1, this is 2, last is 626. So this is how it will be there, image will be. So if you wanted to look for this one, so then I will be saying that like this is 440. So I will be saying 40 pixel. So this is how, then that is the value of this one. So like if you want to look for this one, so this is how. So you should be knowing that like when we say 1200 by 60 means like this image pixel 1200 into 627. So this is a image. So total number of pixels will be the total values. And size, when we see the size of the image, so this is what trying to give 1200 comma 625. So this is what it will give. Any question? Anybody not able to understand this? And since it is RGB, then how many values will be there? So this is for one red color, another one for another color, green color, white, blue, sorry, green and blue. So you will be having so many pixels. It's like 1200 by 627 for one color, another color same, another color same. It's like you'll be having, that is the total vector size. So total vector image size actually. And to represent one pixel, if I'm using 8 bits, then that is a total size. So what is the total size? If you want to calculate, you can calculate the total size. So this into 8, 8 bits. So that is total number of bytes for one channel, and then 3 channels into 3 is the total size of the image size. So if you wanted to get the what in terms of bytes, what we get, so that is what we'll get. Like for example, here Parrot only I opened. What I opened? I opened this as a Parrot only, correct? So this is the number of bytes. So what I'm getting this number of bytes, this byte we will be getting it. So let us see that calculator if ours is matching or not. So 1200 into 627. So this is for one. So this is for one. So now this one into 3 we should be dividing. So 3 channels. So now this one, if I have to convert into a proper byte formats, so what I'll be doing 1024. So it will be giving in terms of kilobytes. So it will be giving in terms of kilobytes. So or else like this will be in terms of bytes 1024. So this is the size of the what is called image in one color. So if you total, if you say, is a 3 times of that. So that is how it looks like. Fine. So now let me, this is in terms of bytes, because I'm not multiplying 8. So one pixel will be represented by 8 bits. So this many bytes will be having it actually. Any questions? Okay. So next thing actually, this is a platelet. So we'll be seeing that like, and we're looking at actually what is the width and what is the height. So let me see that like what are the other parameters we have. So IM dot. So if you see here actually what are the other things we can look into. So it will dot automatically, it will give the lot more things. So you can look into this, see if whatever is something like a cube, these are the functions. These are all functions. And what is something like this is actually the name, like attributes are variables. So that is what we are looking into. So if you want, we looked into mode, we looked into number of frames. So if it is, so info is animated, these are the things like format. So these are the things we looked into. So let me see in terms of bits, if you wanted to convert. So all these things are there, but whatever I'm trying to discuss actually is important. So everything is in 8 bits. So it is taking digitized with 8 bits. That's what I said. So like 1 bit will be represented by 8, must like 1 bits will be represented by 8 bits. So that is what the pixel values are there. So these are the basic information about the image, attributes of the image model. So any questions here? So these are what we are discussing is essential, because we need to know width, net the height. We need to know how many 1 bit pixel is represented by how many bits. That is also essential. Then size is essential, and then which mode is essential, and format is essential, file name is essential. So these are the basic things we should be knowing about the image. So okay, so now what we looked actually, we opened and showed. And if you want to save into some other thing, so how should I do save it actually? So same thing, first I'm trying to open it, then I wanted to show display. Then dot save, I'm trying to save. So I'm trying to give the file for things like so parrot.bmp. So I'm trying to show as a BMP file. So now again I wanted to open and I want to display. So I wanted to show, I wanted to save and then in a different file format, and then I wanted to open and I want to display. So this is how I'm trying to do. So if you wanted to open in another, you want to save in another file format, so like a GIF. So image, this image is variable. See, whatever what we have read here. So that image. So that image. So dot save. So here the file name, and apart from that, like file type. So I wanted to save it as a GIF file. So I'll be trying to save as a GIF file. So any question? It's taking time. So let it take time. Any question? I think my system. Yeah. Okay. So we did open, we did show, we did and saved it to something. So I'll try to save into zip file. Then I will try to open the zip file. So all this is the basic operations. Then we want to check actually file format, whether what I have read is zip file or not. I wanted to check actually. So it should show file format is GIF. So it is saying GIF and is animated. So it is not animated. Even if it is GIF file, it is not animated. So still file. So is animated will be false. Right? So this is the thing. So then other than that, actually, I wanted to create a thumbnail. What is a thumbnail? Like, so see, let me see the, like if it is a folders. So this is kind of, this is simple, like, so short images, no? So this is actually the big image, but I wanted to create a short thing so that like, oh, of image of what? So this is image of elephant. So this is image of, I wanted to pick, no? So I wanted to compress it actually, even if you parrot image, let me show that like, where exactly parrot, see parrot image like this small one. So, but actually, what is the size of the parrot? It's too big, no? So this, if you see actually, what is the image? This big actually. So how should I convert it to thumbnail so that like it is very easy to view? So how should I do that actually? There is a function called thumbnail is there. So I'm using it. Open the file, then say dot thumbnail, and in the bracket, I should be giving what size? So 90 by 90 pixel. So it will be 90 by 90 pixels actually. Then I'm trying to show that. Or if you want to split with like a bigger size, so 120 by 120. So you can convert 120 by 20. So there is no necessary that like both should be of same size. You can do whatever the way you want to do. So I just wanted to create the thumbnails. So any question? Okay. So next thing what we look into. So I said no RGB. So color images will be having RGB channels. So if you wanted to segregate, I want R channel, I want G channel, I want B channel, I want all these different channels to be separately. Then there is a function called split. So we saw split function in that string, correct? So when we say split, then it will split wherever there is a space or whatever the information. We also saw split in regular expressions. Like so here, when we say split, so since it is an image, so automatically split between the channels. So red channel, green channel, something like that. So when we say split, so I am trying to extract red channel, green channel, blue channel. And see, for example, I wanted to make red is more reddish. I wanted to beautify more red. I want to make our dim red. Or like you want to do. Then what first I need to segregate and then modify that red channel and then merge it actually. That is the operation we do. So when we say image processing, we'll segregate the channel and do whatever things you want to do for red channel or blue channel, whatever you want to do. And then again merge it and create the image. So now I'm trying to split it actually. The first one will be R, second will be, so this is the order. So first one will be R, second will be G, third one will be blue. So this is RGB. So RGB. So I'm trying to split actually. So now I wanted to show only R channel. So R dot show. I'm just showing the R channel. I want to show only B channel. So B dot show. I'll be showing the B channel. I want to show only G channel. So I'll be showing G dot show. So it will take some time because image, no. So it will take some time to execute. So it is heavy computation necessary. So it is take some time. So I'm trying to do those operations. Any questions? So by the time it display these things, any questions? So it is taking time. See anything when you deal with the image, audio, video, it takes a lot of time. So, and even if you in GPU or something also, it will take a lot of time. And if you have lot of images and then processing, it may take 1 hour, 2 hour, 10 hour, 20 hours kind of things like so. In the chat GPT, what we have seen in the text one, that is trained across all the data available on the global, and they have taken like so many GPUs for 8 months, 10 months they have trained. So it's like training itself took that much time. So that is how it will be. So now I'm trying to show red channel. So it is taking some time to load also. So this is a red channel. This is a blue channel, green channel. Fine. So this is how it looks like. Okay, if you want to merge it back, I have done modification. There is a function called merge. So merge, then I will be saying that like what mode you wanted to merge, RGB. Then I'm trying to give BZR. It's like in the same order you should have given. So I'm giving this order. So modified order, like you should be giving the same order. So depending on this will consider B will be considered as R, G will be considered G, R will be this B will consider that R will be considered B. So I'm merging that actually. Merge in the column, the mode and then the values. So values, and then I'm trying to merge the image and I'm trying to display the merge image. So I have shown this RBZ individual, correct? So now I'm trying to merge it and I wanted to show the merged image, color image. So these are the basic operation. Remove the channel and do some kind of processing and then do. So any question so far? Okay. So next thing is actually like sometimes I don't want it to let it come actually. So sometimes what happens actually, I don't want it to upload the file because I uploading, downloading all those things. Now I wanted to, I know already it is there in the somewhere else in the URL. There is an image URL is there. I wanted to open that. So like, for example, let me show that like actually. So this is the image URL. So it's like this image exists in the net. Let me show that actually. This is where that image exists. I wanted to, so this is the image. So how should I get actually? Copy the image address. So I got this image address and I wanted to display this image in my code. So then how should I do that actually? So one way is actually normal way. You should say save image as in your local file. So something that like you give name and then upload it and then do it. So it's like you will be saving in your local file in your desktop, then again you will be uploading and then demonstrating. I don't want to do all those things directly. Is it possible to do? So is possible actually. For that also you should be using few more libraries. One is actually URL. So this is a URL. This is all about URL. So this is called URL, whatever we display. So this is called URL. URL of a site, image, any data. So now, so since I'm trying to deal with the URL, so I'm trying to import a library URL lib. Lib is library, URL library dot request. So because I need to, the request is no, I'm trying to request to get that image, correct? So dot request is I'm trying to import. From the request, I'm trying to say URL retrieve. It's like I'm retrieving that information. I'm extracting that information. So URL retrieve. So I'm using URL retrieve. So I'm extracting that one. So for URL retrieval, I will be giving the URL. Then I will be giving what, how should be retrieved. So I will be downloading and saving as file name. So something that like, so here, when I give that actually, then I will ask you actually save as something, no? So I wanted to save that as parrot.jpg. So this is what I wanted to save as. So, or like if you want to parrot1.jpg, you can say parrot.1.jpg, whatever it is your name. So I wanted to retrieve from there. And so one information is the link. Second information is the what is the file name it should be stored as. And I'm trying to display that. Like, so I have read that actually, then I have shown. So you can use from URL. Any question? So from your local system and from the URL. These are the basic operations you will be doing whenever you are trying to do processing, image processing. Fine. The next one is actually converting. So grayscale. So from one color to another color. So how should we convert from one to another? It is possible. So there is a function is there to convert into grayscale. So for that function is exist part of not as image model, it is part of image operation, OPS, operations, image operations. Again, what kind of operations you want to do on image? So that model name is image operations. So image operations. So from image operation, what kind of operation I want to do? I want to make it from color to grayscale color. So grayscale. So image dot grayscale, in the bracket I'm trying to give the image. Remaining anyhow I explained, so I no need to explain again. So image operation dot grayscale that image. So the image will be converted to grayscale image. So even though that parrot what I'm trying to read is a color image, but I wanted to convert into grayscale and I want to display a grayscale image. So this is a color image. Like, so here I have, it's taking some time. Okay, this is a color image. So now I wanted to extract, convert into grayscale, and I will be printing the grayscale. So it is taking some time. It will take some time. Any doubts? So these are the basic operations, fundamental operations you will be doing. So converting image to grayscale is very fundamental, and reading in file from Drive, Google, from your local and all those things, open, read, close. So all those things you should be knowing. Any questions here?
No, sir.
Okay. So now I wanted to see. Okay, this is all done. So next thing is actually like the another 2 minutes I will take, then we will end here. So now next, what is I'm trying to do? I wanted to convert. See, this is of pil dot image dot image, but whenever we try to feed to a model, we always feed the numpy vectors. So numpy kind of vectors or vectors we need to convert, but this is not the numpy. This is of type pil dot image kind of type. But I wanted to convert into numpy vectors. Numpy vectors is actually somebody, I think we covered for numpy for some students, but some students were not covered. So we'll discuss that. So how should we convert into numpy? So what exactly we'll be doing? We read into PIL. So that PIL I wanted to convert into NumPy. So this PIL I want to compare. NumPy is actually NumPy ND array is actually NumPy dimension, like n dimensional array. So ND means like n dimensional. So it can be 1 dimensional, 2 dimensional, 3 dimensional, 8 dimensional. NumPy gives an array just like an array, normal kind of array, which of n dimensional. So it can create, and it is much more faster compared to the normal array from the Python or the some C programming. So it is heavily needed. So we'll discuss that little bit later on. But it is array we already know. So multi-dimensional array. So NumPy ND array is actually multi-dimensional array. So what I want to do actually, I wanted to, because I said no. So image will be looked as in a vector. So 1, 2 dimensional. So 3 dimensional. So whatever it may be. So I wanted to convert into NDM array. So instead of that thing, how should I do that actually? There is a library called as array. So when I say as array, so means like I need to convert. So first we should be importing the NumPy. So import NumPy as NP. So this is what I imported. So now as array means like I need to convert as an array. So whatever I'll give input to this, that input you will take it and finally we will convert into an NumPy array as an array. As array is actually I'm asking whatever I'm trying to give to you within this will has to be converted into output should be NumPy array. So I is equal to np dot as an array. So here what I'm trying to give, I'm trying to read that image. So that image, then I'll be getting something like pl dot image. So this image I wanted to convert into a NumPy array. So I will be converting. So if you see here, actually, if you after that conversion, if you see type of that I is a NumPy array. So NumPy dot ND array. So here, if you see that like the image type pil dot image. So that is a type. So now, then what is the size? This is the size. So that is the total size. So now what is the thing? The shape is this shape. So shape is actually 388 by 690. This is the width, the height, and this 3 is actually RGB color, 3 channels. So this is 3 channels. And dim n dimensional. How many dimensions are there? This 1, 2, 3, 3 dimensions are there. No? So I dot n dim, n dimensions. How many dimensions it will give? So 3 dimensions are there. And this is if you multiply this, you will be getting this. That is the value. That is the size, and that is the shape, and there is the n dim. Shape will give. So it will give much more clear shape, no? Width, height, and also color. Like, so if it is 1 or nothing is there, like 1 means like the grayscale image. So if you read the grayscale image, then it will be something that like thing. Any questions? Okay. Next, I wanted to convert it back into something like from NumPy array to image, PIL image. So how should I do? Image dot from array. So it's like from ND NumPy array, I wanted to convert it back into PIL image. So from image, this is this image. So from PIL image, so I'm imported. So that image dot, now I'm saying from ND array, I wanted to convert back into my own thing. So image dot from, it's like I wanted to show that like how should we convert from PIL thing to ND array, from ND array to PIL thing. So from thing. So here what I'm trying to give, that whatever that like. So I'm saying why I'm saying actually every, if the value is, because I wanted to represent only 8 bits, correct? So 1 bit 8 bits only. No, that we discussed here. So if you see that like bits it is showing, it is 8. So I'm saying that like anything. See, if I'm typecasting this like np dot unit, directly I would have given I, but np dot unit means like I'm typecasting. Any value should not be beyond uint 8 bits. It's like any value will be trimmed. So this is not necessary, but because it is already something that like it's a binary uint fashion only. But sometimes no, it is necessary that like you should be converting and then passing them. So this is the I, this is ND array. So now I'm typecasting to uint 8. It's like every value will be of 8 bits only. So then I'm passing to this one, and then it will convert it into something. And now if you see that like what is the type of that, so let me see the type of that actually. So now I have converted into IAM and I'm displaying. So if you want to see that what is the type of that, so you can see type of that. So you can see the type of IAM. So it will be pil.image.image. Any questions? Okay. Then last one more thing which I will be explaining. So now why should I do actually like what happens if only directly I can convert? So you can convert. See, if you read the image and then there is a dot convert and I'm trying to say L. So that is a grayscale kind of notion. So I want to convert into grayscale. So I'm reading the image here and saying dot convert. So I'm trying to convert. So read, instead of 2 steps, first read and then convert, I'm doing read it, then immediately convert. And that whole information I'm trying to pass to as an array. It's like I want to convert into ND array. So that will be input. So now I'm trying to convert. So now then I'm trying to convert to ND array. So if you see here actually 388 by something. So now if you see there is no 3. So it's like it's a grayscale image. So this is a grayscale image, not the. So here if you see that is 3. So it is not there. And if you look up in dimensional, it is 2-dimensional, correct? 2-dimensional are there. So 1 rectangle. So this is how it's converted. So then size also got reduced, correct? If you see that what is the size, so and what is that size? So it is something that like a half, almost all half the size. So any question? And if you wanted to convert it back and display, so from that I wanted to convert, and since it is a grayscale image, so I would got the grayscale kind of image. So till this we will be done. So we'll discuss further things in the next class. Any doubts? So we'll
No,
end
sir.
here. So we'll end the session here. So next we will be discussing few more like things. Like so, next few sessions we will be discussing about PIL and then. So by this one, like next time when we do over the deep learning kind of things, or image thing, you should not come and ask, sir, how should I do? So because we are going very, very deep, and you should be practicing this as much as possible, so that your profile should be far better than the others. That is what my intention. And if you're just coming and listening and not attending, then it will be waste, because I'm seeing that like so many people are not serious. So it is up to them, because if they are interested to learn it, let them come. Or if they are not interested, then they will be losing. And after sometimes we will not be continuing you also. So if that is the, because if you are not gaining, then it is as good as like you are defaming our name. Then you won't be able to get a good job. And so I went in this program, but I didn't able to land anything. Then that is not my fault. Like if you are not regularly coming, not doing the practicing, then it is not my fault. No. So, but if you do it actually, then it will be good, and it is good for you also. It is good for us also. Like we don't want it to damage our name. So that is the reason I'm again and again saying, and I'm waiting so many times, but a lot of people are not attending. So don't take it as a light. And this is my final request for you people. So here again, if you're not coming, then we will be, maybe after some times we will ask some people to discontinue. Fine. Thank you. See you in the next class.
Thank you, sir. Thank you, sir.